Hi, the purpose of this video is to demonstrate LU decomposition. LU decomposition is a way of using formulas to obtain the solution of a system of linear equations. This is used rather than the elementary row operations involved in the Gaussian and Gauss-Jordan methods. The process is lengthy. However, it does use formulas. It is programmable, which is desirable when solving a large system of equations. So the general process involves the following steps. The first thing you want to do is factor the coefficient matrix of your given system such that it looks like this. Okay? So this is the coefficients of your given system of equations, and this is what you want to factor into a matrix L and a matrix U, such that L times U, when multiplied, will equal the coefficient matrix. Okay? Now L is set up so that there is a triangle of zeros right here in the upper right hand corner, and U is set up such that there are ones on the diagonals and everything below it is zeros. Capital L stands for an element in matrix L, and the subscript indicates its location. So this item is in row 1, column 1 of matrix L. This item is in row 3, column 2 of matrix L. Same thing with U. This item right here is in row 1, column 3 of matrix U. And same thing with capital C. So capital L indicates an element in matrix L, where capital U indicates an element in matrix U, and capital C indicates an element in the coefficient matrix C. Okay? L and U. So how do we find each element in matrix U, L and matrix U? You have to take each row of matrix L and multiply it times each column of matrix U. Okay? I'll demonstrate that when we take a look at an example in a few minutes. Okay? But basically the first step that you need to do is the lengthiest step, and that is to factor the coefficient matrix. The next thing that you do before you go any further is to check your work, multiply matrix L times the matrix U, and make sure that you end up with a coefficient matrix. If you don't, then you know you've messed up somewhere. So it's a good time to check that. The next thing is that there are a set of formulas to help us take the original coefficient matrix and transform it into row echelon form. These are the formulas. After your matrix is in row echelon form, then you use a different set of formulas to actually find the values of each variable that was in the given system. And the formulas look like this. All right, and N, by the way, stands for the number of variables that you have in your system. Okay, and I will demonstrate this in a second when we look through the first example. But I think that you can see this is a pretty lengthy process. However, because it uses formulas, it is programmable, and that is desirable when dealing with a large system of equations. All right, so it's time now to take a look at a system and work through all these steps so that you can see how it's done. Here's our system. So the first thing we need to do is factor such that L times U is equal to the coefficient matrix. Now, since there are 4 equations, notice that L and U are 4 by 4 matrices, okay? And your subscripts don't go any higher than 4, okay? So in matrix L, we have that triangle of zeros up here in the right-hand corner. And matrix U, we have ones on the diagonal and zeros below all of the ones. Okay, and then the subscripts for each one are labeled appropriately. So U, this element right here, is in matrix U, and it's in row 2, column 3. etc. Now, as far as these numbers, where did we get those? Go back to the system, and if you look at the first equation, the coefficients are 1 and 0, negative 5, 1. And as you see, what's written here is 1, 0, negative 5, 1. And the next row, let's go back to the system, negative 2, negative 1, 12, negative 3. And you go back and you see that that is what is written here in the coefficient matrix. And the same thing for the other two. Okay, so we've got it set up. Now what we have to do is set up each equation to figure out what L11 represents and what this variable represents and what this variable represents and so on. Okay, so we're about to do that. All right. Okay, so the first thing we're going to do is take row 1 of L times column 1 of U. So that's L11 times U11, L12 times U21, L13 times U31, and then L14 times U41, and it's equal to C11. Okay. So the reason it's equal to C11 is because we're multiplying row 1 times column 1, and you set it equal to the element here that is in row 1, column 1. Okay, so multiplying the two rows, it's L11 times 1 plus 0 times 0 plus 0 times 0 plus 0 times 0 is equal to 1. Okay? And really, everything just drops out because we have so many zeros, and it just tells us that the variable L11 is equal to 1. Now we're going to take this number and plug it into the L matrix because we're going to need it for future equations. And there it is. Okay? So now we take row 1 times column 2 and do the same thing. Okay, so we're going to take 1 times U12, 0 times 1, 0 times 0, 0 times 0 is equal to, and we multiplied row 1 times column 2. So find the element over here in the coefficient matrix that is in row 1, column 2, and it's the 0 right here. Okay, and again, it works out very nicely. So that everything drops out, and it tells us that U12 is equal to 0. Okay? So now we're going to plug that value into the U matrix right here. So each time you do this, you're going to find the value of a variable, and you plug it into the matrix and keep on going. There it is, all plugged in. Okay? So now we're going to take row 1 of L times column 3 of U. So this is 1 times U13 plus 0 times U23 plus 0 times 1 plus 0 times 0, and that is equal to the item in the coefficient matrix that is in row 1, column 3. So row 1, column 3 is negative 5. So you set it equal to negative 5. Okay? So let's see. This drops out, this drops out, this drops out, and U13 is equal to negative 5. So we're going to put negative 5 right in here, replace it, and we have our next equation to work with. So the next one will be row 1 times column 4 is equal to the item in row 1, column 4 over here, which is the 1. So that's 1 times U14 plus 0 times U24 plus 0 times U34 plus 0 times 1 is equal to 1. Okay? So 1 times U14 plus 0 plus 0 plus 0 equals 1, and U14 is equal to 1. So we're going to replace it by 1 here. Okay? And there it is. It's been replaced. Now, we have taken row 1 of matrix L and multiplied it times every single column in matrix U, and we found some values. We're going to keep repeating this process, but go on to row 2. So now we'll take row 2 times column 1, then column 2, then column 3, and column 4. And we'll find more values. And then we'll take row 3 times each of the 4 columns, then row 4 times each of the 4 columns. And as you substitute values for the ones that you find each time, you'll find that every equation will only have one variable in it. So this is row 2 times column 1. So L21 times 1 plus L22 times 0 plus 0 times 0 plus 0 times 0. Okay? The resulting equation gives us negative 2 is equal to L21. Okay? Now why was this negative 2? We multiplied row 2 times column 1. So if you look in the coefficient matrix for the element in row 2, column 1 is equal to negative 2. That's why that value is there. Okay? All right. So substitute that in where it belongs. And now take row 2 times column 2 and set it equal to the element in row 2, column 2 over here. Okay? Check that out. It's negative 2 times 0 plus L22 times 1 plus 0 times 0 plus 0 times 0 equals negative 1. Okay? So L22 is equal to negative 1. I'm going to replace it. There it is. Now we're going to take row 2 times column 3 and set it equal to the item in the coefficient matrix that's in row 2, column 3, and that's 12. Okay? Check it out. Okay, so it's negative 2 times negative 5 plus negative 1 times U23 plus 0 times 1 plus 0 times 0 is equal to 12. Okay? So that's 10. Only 2 terms dropped out this time, but you have 10 here. Subtract 10 from both sides and divide by a negative 1, and U23 is equal to negative 2. So that's going to get plugged in right there. There it is. Okay? And then row 2 times column 4 is equal to the element in row 2, column 4. Okay? So negative 2 times 1 plus negative 1 times U24 plus 0 times U34 plus 0 times 1 is equal to negative 3. Okay? A little tiny bit more algebraic manipulation this time, but nothing that you can't do. So U24 is equal to 1. And I'll plug that in right there. Now we're done with rows 1 and 2, and we move on to row 3. We're going to take row 3 times every column in matrix U. So here's row 3 of column L times column 1 of matrix U. Check it out. It's equal to the item in row 3, column 1. Okay. Then row 3 times column 2 is equal to the item in row 3, column 2. Okay. Check it. We find L32, so we're going to plug that in. Then row 3 of matrix L times column 3 of matrix U is equal to the item in row 3, column 3, which is negative 10. Go through it. And then finally, row 3 of it's row 3 of And finally, row 3 of matrix L times column 4 of matrix U is equal to the item in row 3, column 4, okay, which is the 1. Okay. All right, and U34 is equal to a half. So we're going to plug that in right there. There it is. Okay, and now we're going to do the same thing, finally, with row 4. Row 4, we're going to take times column 1, column 2, column 3, and column 4. So row 4 times column 1 is equal to the item in row 4, column 1 here. Okay. All right, and then row 4 times column 2 is equal to the item in row 4, column 2. Okay, so that gives us L42. Then row 4 times column 3 is equal to the item in row 4, column 3. Follow through. Okay, and that gives us L43. And then the very last one, row 4 times column 4 is equal to the item in row 4, column 4. Okay. And that gives us the value for L44. Okay. The coefficient matrix is factored, and this, again, is an excellent time to check it on MathCAD. Multiply what you have for matrix L times what you have for matrix U, and make sure that you get the coefficient matrix, okay? Because then you know so far all of your work is correct.